Okay, so for today's class, we have logs and exponential exponents. They both are related to one another. Exponential functions, you have seen them before. Exponential functions are when your variable is in the power. For example, 5 power x, 10 power x square, y is equals to 5 power x, and something like this. These are called exponential functions. Why? Because you can see that your variable is in the power. Exponential functions. Because you can see the variable x is in the power, exponent is power, and you have seen how to solve exponential equations in your O level IGCSE. For example, if you have 2 power x plus 2 is equals to 8, they're asking you to solve. Now this is an example of an exponential equation, because you can see the variable is in the power. Exponential equation, this is an exponential equation. You can see the variable is in the power, and you have done some rules of exponents in your IGCSE and O level. Those will be carried forward over here. And to solve this equation, what do you have to do? The rule was that if you make the bases same on either side of the equation, 2 power x, 2 is the base and x is the power. So on either side of the equation, if you can make the bases same, then you can equate the powers. So 2 power x plus 2, you can't do anything to this one. You can do this thing. You can write 8 as the power of 2. 2 cube is your 8. So now you can see the bases are same. 2 and 2 cancel out, and then you can equate the powers. So x plus 2 is equals to 3. And so your answer comes out as 1. This is your answer. This is how you solve exponential equations. And this is something you have done in your IGCSE and O levels very much in detail. In your AS maybe also sometimes this is applicable. Then why do the logs come in then? For example, now if they ask you to solve again, look at this example. If you have 5 power x is equals to 3. Now how will you solve this? This is a sort of a, you can say, exponential equation, because you can see that the power is a variable, the thing that you want to find out. But you cannot find it out using the rules that you have done of indices. And indices, we have learned that if your bases are same on either side, then you can cancel out the bases and equate the power. Over here, you cannot make, you don't know what power of 5 will it give you 3. Right? You cannot write this 3 number 3 as a power of 5. You don't know that. So this is where logs come in. This is where logs help. So first of all, you have to understand how do you convert your exponential equation to a logarithmic equation and a logarithmic equation into an exponential equation. Logs to exponent and exponent to logs. So a generalized format, let's suppose it is a power x is equals to b, or a power b is equals to c. This is a sort of a, you can know this is a exponential equation. And if you want to convert it into logs, so what do? This is called the base, this is the power, and this is the answer right now. This is your base, this is the power, and this is your answer. And if you convert it into logarithmic form, this changes into the base becomes the base of the log. Log is log, log, and the base is still the base, a. The power comes outside the is equals to. So power comes over here, outside the is equals to. And your answer, c, comes inside the log, like this. So this is how you can convert your exponential to log and from log to exponential, whatever the need be. Right now in this example, we want the answer for x. 5 power x is equals to 3. And this is an exponential function. So using the rule over here, if we convert this 5 power x is equals to 3, this would become log, and the base will still be the base. So 5 is the base. The power comes outside is equals to x. And the answer of the, after this equals to part, it comes inside the log. This becomes log 5, 3. Log with the base of 5 and 3. So x answer is log base 5, 3. So you can write it down, log base 5 and 3. And you can find it out, look, 0.682. This is your answer. 683. This is your answer. This is how the logs can help you solve exponential functions. Sometimes your logarithmic equation cannot be simplified, cannot be solved, cannot be used to further solve the answer. So you convert it into exponential form. So these two formats, they are interconnected, they are linked to each other. So according to the need, we convert them from this to this or from this to that. This is where the logs are coming in. For example, let me give you another one. If they ask you to solve 10 power x plus 2 is equals to 20. Now again, you cannot write the 20 as a power of 10. So you will convert it into logarithmic form. So log with the base of 10, because the base in the upper equation is again 10. And after the is equals to it is written 20. So that comes inside the log. And whatever the power is x plus 2 comes outside. So x plus 2. And now to find the value of x, the 2 would go over there and subtract. So log 10, 20 minus 2. And that would give you the answer. Log 10, 20 minus 2. So negative 0.699. This is your answer. Any questions till now?
Nice, sir.
Good. Now we will learn more about logs because you have done in detail the exponential. So I don't think that I need to explain or write down all of the rules of the exponent. You know the bases are same, and when they're multiplying, the powers add. When the bases are same and they are multiplying, and when they're dividing, the powers subtract. Power to the power, then the powers multiply. Those are the rules that I know that you people know about it. If you don't, then let me know. I'll share you a recording or something. That is the simple part. You just need a few revision on the little revision, and you will get it. The important part is learning the rules of logs. So now you know why logs. क्या हुआ?
लॉग के रूल्स मुझे नहीं पता.
Logs की right now.
पढ़ी मैंने.
Yes, we will do. I was talking about the exponential rule. Bases are same. अभी log से we will discuss the log rules, right? Okay. Now there are 3 types of logs. Basics. Types of, for example, types of logs. With respect to base of log. So if your base of the log is 10, log and base of 10. So you can write it down. You don't need to necessarily write log of 10. You write it down simply LG or simply LOG. These 3 means the same. So if they have just written down LG or if they have just written down LOG, log, without any base, this means that the base is 10. It's the same thing. Then another one is log of E, base E. E is a constant, special constant or irrational constant, just like pi. E is like this, E. And the value of E, look, it is an irrational number. 2.718281. You don't need to memorize this, but this is just something, a rational number, irrational number. And if the base is E, then you write it down ln. LOG, if the base is E, then you write it down short form ln. Ln is also called a natural log. So don't be startled if you see ln. This is natural log. And the third one is the regular log. If you have log and if you have written anything over here, 2 or 5 or 3, if there's any other base other than this 10 or E, they would write it down over here like this. If it is log 5 or if it is log 7 or if it is log 12 or anything else, they would write it down, the base. Otherwise, if the base is 10, they would write LG or LOG. If the base is E, then they would write LN. They would not write the complete LOGE. They would just write this one. So these are the 3 types of logs. The rules are all the same. You can apply all of the rules that you will learn right now to any of them. Okay. So now there are these rules. Here I have written down the rules of exponent. You have seen this before, I know. A power n multiplied by a power m. The powers add up. N plus m. If they're dividing, then the power subtract. Look, power to the power is 0. Anything to the power of 0 is 1. And when you have a negative power, you can just do reciprocal and your power sign becomes positive. The sign changes. And this is the one which we just revised, that if solving exponential equation, if your bases are same, then you can equate the powers. And here is the example which I solved. Look, I converted the 4 into 2 square and then the bases cancel out and I found the value of x. And now these are the rules that you have to follow, that you have to learn. Memorize not, it's okay. You will eventually, after some practice questions, you will eventually see that you have memorized it. No place here. So look at the first one. Look, you can see that the bases are same. So there are two logs with the same base a, and they are adding. So when this happens, then you can multiply the insides. B and C, they multiply. The base still remains a, but the insides of the log, they multiply. Then the second look at it as an example, base was 3, 3, and then you have 2 over here and 7 over here. So the inside, it would become 14 now. Insides will multiply. Then they are divided. If they are subtracting, if the logs are subtracting with the same basis, then the insides would divide. But then you have, if the bases and the inside is same of the log, then it is simply 1. So look, log 3, 3 will be 1, log 4, 4 will be 1, log 70, 70 will be 1. Similarly, ln e will also be equal to 1. Because I told you ln means the base is e and the inside is also e. So if the base is e and the inside is e, so answer would be 1. Similarly, lg 10, this would also come out as 1. Because of the same reason. The base of lg, we know it is 10. And inside of the log is again 10. So log 10, 10 would be 1. So anything, any log with the same base and the same insides would be equal to 1. Then this is one of the most important ones. The power rule. So you look, you have log a and b power m. The inside is raised to a certain power. Inside. So what happened? You can bring the power down and multiply. So it was b power m. So the m came down and multiply with the complete log. So look, log 7 2 power 3. So the 3 can come down. So this becomes 3 log 7 2. And similarly, it can go up back again as well. Log 7 2 cube as well. You can go again to the power as well. It's the same thing. So log 7 2 power 3, the 3 can come down. This is the power rule. And similarly, if there's something, let's suppose it is 2 over here. So this 2 will come in the power and multiply with 3. So 2 power 6. So it can go both ways. Whatever the rules that you can see over here, they go both ways. Okay, both ways. Whatever the identity that you learned, they go both ways. So जरूरत के हिसाब से, according to the situation, you use this. You use the relevant rules. Then power rule, there's something that I've written over here. These two are not equal. Look, log a base is a inside power m. Now the m can come down and multiply. But in this case, the entire log is raised to a certain power. This is something different. Over here, the complete log is raised to a power, and over here, only the inside of the log is raised to a power. So both of these things are different. This is the one where this rule will be applied. The power comes down and multiply. Then you have the fifth one. When you have the same, this will help you to solve the logarithmic equation. When you have the same base on both sides of the equation, you can cancel out the bases and the insides can be equated to each other. So log a m plus 2, log a 6 plus n. So log a cancel out, and then you can equate the insides. Copy down these rules for now. This is where I've written special logs according to the base. So if the log has the base 10, then you can write it down LG or LOG. And if the log has the base e, then you can write ln, natural log. And here are some examples to do. And using these rules to help you solve this logarithmic equation. Now you can see why do you call this logarithmic equation? Because your variable, the thing that you are trying to find is inside the log. X is inside the log. So you have to somehow move things around and use the rules that we have learned. Either we convert it into exponential form or use logs to further solve this. Okay, let's take this example. Log 3 x plus 5 is equals to 2. Now there are two methods of solving this. One of them is to use exponential form, convert it into exponential form. So I told you the base of the log and the base of the exponential form, it is the same. So base is 3. Then whatever is the power of the exponential form comes outside the log is equals to log. This is your power. If you can recall, it was a b is equals to c, and this becomes log a c is equals to b. So whatever was the power was outside this equals to. And similarly, I can bring them back in the power as well. So over here, outside the log, outside this equals to, we have 2. So this will come in the power of the base, 2. So this becomes 2, 3 power 2 is equals to x plus 5. So this becomes what? 9 is equals to x plus 5. And so your x will come out as 9 minus 5 would be 4. This is it. This is your answer. This is how you solve it. Another method is still using logs, rules of logs. Now I know one of the rules of logs is that if I can have both sides the same log with the same base, then I can cancel out the logs. So what do? I keep the log over here, log 3 x plus 5. And the base of the logs that we are working with, that is 3. So what do? I multiply the 2 with log 3. Isn't it? Because I told you if the base is same and the inside is same, it is equals to 1. So it doesn't matter if I write log 3 over here. But why do I write log 3 over here? Because I want to have the same log on both sides. So the 2 now, using the power rule, I can bring this 2 into the power of 3. So this becomes log 3 square. And over here, this becomes log 3 x plus 5. And you can see the log bases are same. So log 3 cancel out with this log 3. And you are left with x plus 5 is equals to 3 square is 9. And so your x answer is coming out as 4, the same. So look, both ways, you got the same answer. Either converted into this exponential form or using still the rules of logs. Any questions?
Nope.
Okay, I'll do another one. Whatever the rule that you find is you're more comfortable with, you can go with that. You
The
have
second
log,
one also you.
same है, log 2. Second वाला आसान है.
Second one also confusion you which case.
I also felt this converting from log to exponential. I used to make mistakes. I preferred this one. I don't know why. Maybe the same reason as you. I prefer to do it using still the logs. So log 2, 3x minus 1, and 5 I multiplied with the same log 2 and same inside. So this would become log 2 power 5. Log 2 3x minus 1. So same base, log to cancel out. 3x minus 1 is equals to 32. And so your value of x will come out as 11. This is your answer. You can copy it down, the examples, and then we'll move on to a different combination. Now using more rules together and trying to solve the equation. So question number 3 part A. log 2x plus log 2x minus 1 is equals to log 220. Now I cannot do anything on the right side. On the left side, we learned a rule where if the bases are same and they're adding up, the insides would multiply. So log 2 and the insides would multiply x times x minus 1 is equals to log 220. And so log 2 and log 2 cancel out because same log on both sides. And now you can simplify x square minus x is equals to 20. And then x square minus x minus 20 is equals to 0. And use your calculator, get the answer. You will get, I think, x is equals to 5 and minus 4. Isn't it? One minus 1 minus 20 minus 4 and 5. Yes, but you will see that you will have only one answer, which this would be the only answer, log 5 positive, because this log cannot work for a negative number. You can see if you use a calculator, you will get the answer of log 2 5, which is number. But you won't get an answer log 2 minus 4. Look, it is in iota. 2 plus 4.532 and something. At the end, you can see iota. So this means there is no solution, no real solution. So there is only one answer. In this case, it is only x is equals to 5. Log doesn't work for a negative number. So this is the only answer. And this is how you would solve it. So you use the rule of log, simplified, cancel out the logs, and then it becomes the normal question, easy one. Okay, I'll do one more and then you people can try them. I will do question number part D. Part D is 3 plus 2 log 2x is equals to log 2 3 minus 10x. Okay. The 3, I can write down the 3 as 3 log 2 because I want to bring the log with it as well, so that I can say, add them, simplify them. If I move this 2 on the power, this would become log 2 x square is equals to log 2 3 minus 10x. Then this 3 would also come in the power. So 2 cube. So this becomes log 2 cube. And then the bases are same, so they would multiply. So log 2 cube multiplied by x square. Because they are adding up. Log with the same base are adding up, so the insides will multiply. So log 2 3 minus 10x. And now you can cancel out the logs. Logs cancel out. 8x squared equals to 3 minus 10x. So 8x squared minus plus 10x minus 3 is equals to 0. So your answers are coming out as 8, 10, minus 3. So x is equals to negative 1.5 and x is equals to 0.25. So look again, your x won't work for a negative number. So you will cancel out this one. This is the only answer. Any questions, anyone? Arham, Mohit? All good?
Nice, sir. All good.
Good. Copy down this example. This is a good one. You're applying almost all of the important rules over here of logs. Okay, so you people have done this one, got the right answer. That's very good. Now these are the same things, but involving, look, ln. But I told you they work the same way. So if let's suppose we take this one, 2 ln 2x plus 1 is equals to 2 ln x plus ln 5. And these are very past paper like questions. The past paper also you see very similar ones. They're asking you to solve for x. So over here as well, if we have the same log on both sides, we can equate the insides. So what can I do? First, I bring this 2 to the power because I want to have log only, ln 2x plus 1 whole square is equals to, this would become ln x square plus ln 5. And now ln, they're adding up, so the inside would multiply. So 5x square. And this is ln 2x plus 1 whole square. Now the ln can cancel out. So 2x plus 1 whole square is equals to 5x square. And now you will expand it, simplify, get the answers for x. So 4x square plus 4x plus 1 is equals to 5x square. Move everything on one side. So x square minus 4x plus 1. 1 minus 4, 1. So x is coming out as negative 0.268. And the other one is 3.732. These are the two answers. So you use the same rules. There was nothing different. So all of these ones, question number 9, question number 10 as well. Question number 10, they're just asking you to write x, y in terms of x. So you have to get rid of the logs and then make y the subject. Again, the same rules. Question number 11 is something interesting. 11 is question number 11 part. Let's do 6 e 2x minus 13 ex minus 5. Now this is disguised quadratic. And after doing after converting it into a quadratic equation, you will solve it and then use the substitution back and get the answer for x. So in this one, you can see if let m, any other variable, be e power x. So this would lead you to m square being e power 2x. So now you can replace the e power 2x with m square minus 13 m minus 5 is equal to 0. And then you solve the same way for, now you will get answers for m. So your m is equals to negative 1 upon 3 and m is equals to 2 upon 5. Oh, sorry, 2.5. But you need the answers for x, not for m. So you substitute the variable back. E power x is equals to negative 1.1 over 3 and e power x is equals to 2.5. Now what do you do? One more thing. You can either convert it into logarithmic form, get the answer. Another thing that you can do is ln on both sides. This is something new. Taking this also helps. ln on both sides. This is also which I have used a lot in my time. There are other rules as well that you can use to solve this, but this is the best one which I used in my time a lot. So ln e power x, just like you can cancel out the same ln's on both sides, you can put in the ln on both sides. So ln negative 1 upon 3. Now we know this is not solvable because ln doesn't work, the logs doesn't work for a negative number. So it cancels out. So ln e power x is equals to ln 2.5. The power x can come down. So x ln e is equals to ln 2.5. And ln e we know it is equals to 1. Same base, same inside. So x is equals to ln 2.5. Do you get it? Any questions, anyone? Okay. So this is one more thing that you have learned. They can ask you, they won't tell you to use substitution. But you will see eventually that in some questions, substitution will help you to simplify the things before you find the solution. For example, in this question, 5 power x minus 1 is equals to 5 power x minus 5. Or in the question number 7 as well, 2 power x. You can just take a substitution. You can replace this 2 power x with some other variable. Solve. Get the answer to that variable and then replace it back, find the value of x. Explore this thing a bit. Right now, I want to do even more difficult, I think the more complicated part, which is question number 13 in this picture. Okay, so look in this one. Answer So first of all, you have your variable in the power of e, in the power. And then to add the spice, they have put in an ln also outside. So first we will have to bring out the e power 2x outside the ln, outside the ln. Then we'll have to bring out the x outside the power. So let's see. So what you can do is, first of all, you can bring the 2 over the other side. This would become 1 upon 2, which is be 0.5. Now to get rid of the ln, I give the same base, same inside. So 0.5 ln e. So this would become ln 3 minus e 2x is equals to ln e power 0.5. And now you can see the bases are same. Sorry, the ln's are same. So ln cancels out. So you have 3 minus e 2 power x is equals to e power 0.5. And now simplify, let's see, this would become 3 minus e power 0.5 is equals to e power 2x. And now I want to get the x outside the is equals to, outside the power. So I told you take ln on both sides now. Now put in ln yourself. Now this will help you. Now this ln 3 minus e power 0.5, this is just a constant. You will then put in the calculator, you will get the answer to this thing. And over here, look, 2x can come down and you will get ln e. Ln e will be cancelled out. So your x answer will be ln 3 minus e power 0.5 upon 2. This is the answer. And then you can use your calculator to convert it into a decimal. The question will not be more difficult than this one. If you understand this thing, how the things are moving, when to use which, and how are we using those, so you will easily get this chapter. Okay. Let's do some questions from the past papers. Look, similar question. Question number 10 is the same as this one. 2 ln 5 minus e. Only the difference, I think, is of the power. Yes, e power minus 2x. And over here we have plus 2x. Otherwise, it's the same. Look at this one. Question number 11 is the more interesting. Now you can see the variable that you are trying to find. It is in the power. So definitely we will have to somehow bring the logs in so that it can bring the power, the variable down outside the log. Oh, sorry, outside the power. So what we can do, you have 5 2x minus 1 is 2 3 power x. You can take ln on both sides because you want to bring down the power. So what would this become? 2x minus 1 comes down ln 5. And this is inside the log, there are two things multiplying with each other. Inside the log, you have ln 2 and you have 3 power x. And using the rules of logs backward, you can now separate them. ln 2 plus ln 3 power x. Isn't it? This we have used the first rule of log in the opposite direction. So that we can separate the things which are multiplying inside the log. And now, if you expand this, this would become 2x ln 5 minus ln 5 is equals to ln 2 plus the 3. The x can come down. So x ln 3. Bring both the x together. So 2x ln 5 minus x ln 3 is equals to ln 2 plus ln 5. I brought this thing on the right side, this thing on the left side. And now take x common. So 2 ln 5 minus ln 3 is equals to ln 2 plus ln 5. X comes out as ln 2 plus ln 5 upon 2 ln 5 minus ln 3. This is your answer. Giving your answer correct to 3 significant figures. So you can use your calculator, get the answer. Any questions, anyone?
Nice.
Easy or difficult?
ठीक है सर, with practice हो जाएगा.
This needs practice. So 1.09. This is your answer. Copy this down. We have done almost I think everything, every different types of question that can come in logs. We have done substitution, we have done solving logarithmic, how do you multiply, divide, and cancel out the logs on same side and then solve for the variable. In this one, you have to deliberately bring in the logs so that your power, the variable in the power can come down. Take the screenshot or copy this down. And I think this is enough for today's class. We have done a lot of information. I'll share you this worksheet. Do the practice timely.